Geometric series. What is a geometric series? It's any series like this in this form. B plus B times a number, A, plus B times the same number. So the previous term times A, be A power 2. This term times A, be A power 3, etc. So without a stop, this series is called geometric series. It could be noted like this: sigma b times a power n from n equals 0 to infinity, or b outside sigma a power n from 0 to infinity. So for example, let's take some examples with number. First example, if I take 1 plus 1 over 5 plus 1 over 25 plus 1 over 125 plus without stop. So this is sigma 1 over 5 power n from n equals 0 to infinity. The second example, if I take 1 plus 2 plus 4 plus 8 plus 16 plus without stop. So this is sigma 2 power n from n equals 0 to infinity. So the answer here is infinity. But what about the answer of this sigma, the first one? Is it a number or it's infinity? So we will see in the next theorem that this is a number because 1 over 5 is between minus 1 and 1. So this, the sum here, will be using a theorem. It's 1 over 1 minus 1 over 5. So this is the next theorem. If a, any number between minus 1 and 1, so the sum 1 plus a power 2 plus a power 3, etc. without stop will be 1 over 1 minus a. Okay, how to prove this? If we suppose that the sum 1 plus a power 2 plus a power n equal Sn, so we can write, if I product this term by a, what is a times Sn? It's 1 plus, it's a plus a power 2 plus a power 3 plus, before this term a power n, there is a power n minus 1. So I can write here a power n minus 1 times a power n plus this term a power n times a power n plus 1. Now let's subtract these two equations. So after subtraction, we will have, after cancellation, we'll cancel it a with a power 2 with a power 2, etc. A power 3 would be cancelled here, and also a power n with a power n. So I will have 1 minus this term here, a power n plus 1, equal Sn minus Asn. So Sn minus Asn. If I take Sn outside as a factor, so I will have 1 minus a power n plus 1 equals Sn times 1 minus a. So finally, I will have 1 minus a power n plus 1 over 1 minus a equal Sn, which is sigma 1 plus the sum of 1 plus a power 2 plus a power 3 plus a power n. So if I put a, if let's take n goes to infinity, when n goes to infinity, what is a power n? What is a power n? A power n will goes to 0 because a between minus 1 and 1. Remember that if I take 2 power n, what is the limit of this when n goes to infinity? It's infinity. What is the limit of half power n when n goes to infinity? 0. So if the number a, like a half or any number between -1 and 1, always a power n goes to 0. So the limit of Sn, so limit of Sn when n goes to infinity will be 1 over 1 minus 0 over 1 minus a, which is 1 plus a power 2. If n goes to infinity, I will not stop, the sum will be to infinity. So this proves my theorem. Okay, let's take some examples. So here, this sum from 0. Remember that always this theorem, the beginning must be 0 to use this theorem. So the beginning is 0, so it's 1 over 1 minus a half. So it's 1 over a half, so it's 2. The final answer is 2. And this sigma also could be written as 1 plus a half plus 1 over 4 plus 1 over 8 plus 1 over 16 plus without stop. The answer of this is 2. Next example. Here the beginning is not 1, but always, this is a geometric series because always if I product by a half this term, I will have the second term. Product by half, I will have the third term. So what a geometric series by definition, if each term is produced by a number constant a, I will have the next term. So now if I take 1 over 4, this series will be equal to 1 over 4, 1 plus 1 over half. 1 over half times 1 over 4, it's 1 over 8. 1 over 4 times 1 over 4, it's 1 over 16. 1 over 4 times 1 over 8, 1 over 32, plus without stop. So it's 1 over 4 times. This sum is calculated in the example 1. The final answer was 2. So 1 over 4 times 2, the answer is a half. Next example. Here, this is sigma minus a half power n. If I give n 0, I will have 1. So from n equals 0 to infinity. If I give n 1, I will have this term. This is for n equal 1. This is for n equal 2. This is for n equal 3, etc. Here minus. Okay. So because minus a half between -1 and 1, so I can use the theorem. It's 1 over 1 minus a half. So it's 1 over 3 over 2. So the answer is 2 over 3. The next example here, 3 power n. The number 3 is bigger than 1. So the answer of this series, it's not a real number, doesn't exist. So if you write, it's for n0, it's 1 plus 3 plus 3 power 2 plus 3 power 3 plus without stop. So the addition here is plus infinity. Will give me plus infinity. Example number 5. So here the first term is 8, not 1. So let's take, so this is equal to 8 outside. Let's take 8 outside. Here I will have 1 plus 2 over 8, 1 over 4, a half over 8, 1 over 16, 1 over 64 plus. So this is 8 times sigma 1 over 4 power n from 0 to infinity. So it's 8 times 1 over 1 minus 1 over 4. So it's 8 times 4 over 3. So the final answer is 32 over 3. The last example, sigma pi power minus n over 2 cosine n pi. What is cosine n pi? What is cosine pi? It's minus 1. What is cosine 2 pi? It's 1. What is cosine 3 pi? It's minus 1. Cosine 5 pi, also minus 1. Cosine 4 pi, 1. Cosine 6 pi, 1. So cosine n pi will be equal to minus 1 if n is odd number and 1 if n is even number. So this is equal also to minus 1 power n. So we have here a rule that cosine n pi equal minus 1 power n. So I can write this series as sigma. So this term is pi over minus n over 2 could be written as 1 over pi power 2 power n power a half power n, and the half is the root from 0 to infinity times minus 1 power n. So also it could be written as sigma minus 1 over root pi power n from 0 to infinity. So this number minus 1 over root pi, it's between 1 and minus 1 because pi is nearly 3 between minus 1 and 1. So I can use the theorem. So the sum is 1 over 1 minus 1 over root pi. So the final answer is pi over root pi plus 1.